Welcome back, everybody. This is lesson 7.5. We're dealing with radians on the unit circle. I did post a video in Google Classroom that talks about and kind of visualizes where radians come from. So please go watch that. It's like a minute and a half or something. It's not that long. It just kind of shows you why we have the measurement of radians. And like where it comes from. Basically, we have radians because they're kind of unitless. It's not in degrees. It's kind of just a straightforward number because on every single circle, we have 2 pi radians around the whole thing. So if you guys have a unit circle like what we did last week, as you go around it, so here, you'd have 0. Up here we would end up, all the way across we'd have pi radians, and then if we came back around again, instead of 360, we would use 2 pi. And it does, I hope it makes sense, because if you guys remember back from elementary school, the circumference of a circle is 2 pi r, and we're saying that if you take the radius and wrap it around a circle, it'll wrap it around 2 pi times. So all the way around a circle is 2 pi times whatever the radius is. And that's kind of how we get radians. So please go watch that video so you can kind of understand what I'm saying. And we're going to be getting into solving problems. So going from radians to degrees and then actually solving some angle measurements. Okay, so right here we are going to kind of just say how we go from degrees to radians and radians to degrees, and then we're going to do an example of each. So if you're going to be going from degrees to radians, what you do is you multiply by pi over 180. That will get that pi in there that we have for radians, and then the dividing by 180 will reduce it down. And if you're going from radians to degrees, you multiply it by the reciprocal, so 180 over pi. So what we're going to do, we're just going to do 2 examples of this just so you guys can kind of see how we do it. Again, you can find these conversions online. It is good just to kind of be able to reason through them and kind of logic through them on your own as well. But I will show you how we do this. So for the first one, what we are going to do is we are going to be converting from degrees to radians. So we are going to take, we are going to take 210 degrees, and we want to turn that into however many radians that is. So to do this, we need to take 210 degrees, and we're going to multiply it by pi over 180. Because pi over 180 is a fraction, I'm going to put the 210 over 1 just to make sure we hold our place. I'm going to do some simplifying. I notice these are both divisible by 10 because they end in a 0, so I'm going to cross that off. And then I am going to reduce the 21 and the 18. I know that 3 goes into both of those. 3 goes into 18 6 times, and 3 goes into 21 7 times. No more reducing that I am able to do, so I'm just going to multiply straight across. I get 7 pi for the numerator, and on the bottom we're left with just 6. So that means 210 degrees is 7 pi over 6 radians. What I've done is I've pulled up the unit circle here so we can kind of look at why 210 is 7 pi over 6 radians. And I hope that you can use this to kind of figure out the degree or the radian measurements instead of having to do, all this math step of multiplying by pi over 180 or 180 over pi. We know that all the way to 180 degrees is pi. And if you notice, let me get my highlighter right here, we have 7 pi over 6. So what that means is we took pi and we cut it into 6 equal amounts. So here's 1, and then 2, 3, 4, 5, 6. And then, we went 1 more because we have 7 pi over 6. And I know it looks kind of sloppy, but if you look at it, we went all the way 180. And then because we cut pi into 6 pieces, each of these is 30 degrees, right? So if I'm 30 degrees past 180, 180 and 30 degrees is 210 degrees. So I don't know. The more you do this, the easier it'll get. It probably seems kind of weird right now, but if you're good at dividing by sixes, dividing by threes, or dividing by twos and fours, you should be able to kind of shorten this up some. Main thing that I remember is that 180 is pi, and then I always go from there. So hopefully that helps you. The next problem we are going to do is going from radians to degrees. So we are going to go from 3 pi over 4 radians, and we want to know how many degrees that is. So I'm going to do it the math way, and then I am going to do it with the unit circle. So for the math way, what I'm going to do first, I have to take my 3 pi over 4, and I need to get rid of that pi. So that's how I know that I'm going to be multiplying it by 180 over pi. Because when I do that, then I'm able to cancel out my pi's. And that's how I always remember which one to do when I'm doing this. Then I'm going to see if I can reduce any further. I can actually simplify 4 and 180. 4 goes into 4 once. 4 goes into 180 45 times. Then what I'm going to do is just multiply straight across. 45 times 3 is 135. That means that 3 pi over 4 radians is 135 degrees. Now, if we were to do that with the unit circle, let's see, I'll add in another one. If we're going to do that with the unit circle, what I notice, and again with my highlighter out, we're taking pi and we're cutting it into fourths. So if I'm going to section off each fourth, right, pi into fourths, that means it's going to be sectioned there, there, and there. That is pi cut into 4 equal pieces. And I notice that those are, half of, it's just 180 cut into 4, which is 45. So 45, 45, 45, 45. And in this problem, I actually only need 3 of them. I need 3 pi's cut into 4. So what I'm going to do, I'm going to need to go from 0, one set of 45, another one, and another one. And then I remember that this spot right up here is 135 degrees because it is 90 plus another 45. So again, 90 plus another 45 is 135 degrees. I prefer this way because one, it kind of gets your brain thinking, kind of gets you being a bit more logical about things. And it's just good practice to switch between them so you don't have to waste your time getting out, pencil and paper and working through this. Am I multiplying by 180 over pi or pi over 180? It just helps make it easier for me. So that's how you convert between the two. And what we are going to do next is 2 examples where we have to find cotangent, and then we're going to do cosine. And I might throw in another one. We'll see. What we are going to need to do here is we need to find cotangent of pi over 4. Like I said, like using the unit circle to figure that out, what pi over 4 is. If you want to do it the math way we just learned, you can do that. I'm going to give you time to pause and figure it out for yourself, what degree measure pi over 4 is. Okay, so for me, what I do, I'm just taking pi and I'm cutting it into fourths. Again, remember pi is 180, and if I am cutting that into fourths, that's cutting it in half and then half again. I just need one of them, so I am going to be dealing with a triangle right here, okay? And that was at 45 degrees because it is half of 90, or a fourth of 180, which is pi over 4. So the triangle I am going to have is going to be a 45, 45, 90 triangle. So I'm going to draw the little 45 down there. If you remember, this side is A, this is A, and this is A times root 2. Going to need to fill in my opposite, adjacent, all of that as well. So this would be my adjacent. This would be my opposite, and this would be my hypotenuse. Hopefully you guys remember from our last lesson, the hypotenuse is always, always, always a certain value on the unit circle, and that value is 1. So just like before, I'll do it over here in the corner. I know that a times root 2 equals 1 because the hypotenuse has to be 1. And then I'm going to divide by root 2 on both sides. I get a equals 1 over root 2, which we have to rationalize. So times root 2 over root 2. And I end up with a is root 2 over 2. So I'm going to go ahead and fill in those values. So this over here is root 2 over 2 because it's a, and this is the same, root 2 over 2. Now I'm going to get into actually solving, and you should be able to do this after last week. If you want to pause, feel free. Okay, so I'm going to have cotangent of, well, let's just do of theta first. Cotangent of theta. Remember, it's the reciprocal of tangent, so it's going to be my adjacent over my opposite. Let's plug in the values. Cotangent of pi over 4 is my adjacent, which is root 2 over 2 over the opposite, which is again root 2 over 2. Hopefully you can kind of think about this and logic through this. Cotangent of pi over 4 is root 2 over 2 over root 2 over 2. So the same thing over itself is just 1. So again, just writing that a little bit nicer, we have the cotangent of pi over 4 is 1. Okay, the next problem is find sine of 3 pi over 2. I'm going to let you guys try to do this one. Again, the only new thing here is figuring out what degree measure is 3 pi over 2. Everything else is a review from last week. If you need last week's notes out with you, feel free to have them out. But I hope this will be pretty quick today. So sine of 3 pi over 2. Go for it. I was checking to see how many of you guys paid attention to the end of the video last week. So 3 pi over 2, again, we're taking pi and we're cutting it into halves, and then we are needing 3 of those. So if I go all the way around the circle, let's do that with the highlighter. So I go half of a pi, another half of a pi. I don't think you can see the yellow. Let me actually change it really quick. Half of the pi, another half of the pi, and then the third half of a pi. Takes me to 270. My adjacent has been squashed to basically nothing. Remember, your opposite is a -1 because it's going down, and then you just get -1 as your answer. We are going to do one more, so let's get this scooted over. And what I'm going to have you guys do is you're going to be finding the cotangent of 5 pi over 6. So just a second, I'll get it on the screen. Okay, so cotangent of 5 pi over 6. Please do that, and then you guys can check back for the answer. This is what you should have for your answer for this. Again, we took pi and we cut it into 6 pieces, pi over 6. So when we cut it into 6 pieces, each piece is going to be 30 degrees, and we only need 5 of them. So I end up where I was on the unit circle. I recopied my triangle and filled out what all the side lengths are. You guys should, I hope, be getting really good at doing this. If the hypotenuse is 1, that means a is 1/2 for 30, 60, 90. So you get a half, and you get a negative root 3 over 2, again, because that x value is going back, right? So we are here, we are going from the origin left. That means, again, I don't know if you see the yellow, from the origin going left, that means that it's going to be a negative value down there. Also, we are in the second quadrant, which is the S. All students take calculus. And in here, sine should be the only thing that's positive. Cotangent is like tangent, not going to be positive. So what I did then is I did my adjacent over my opposite. Adjacent was that root 3 over 2 here, and my opposite was a half. Complex fraction. This should be getting very simple for you at this point. turn that into multiplication, flip the bottom, I end up with a negative root 3 over 1, which turns into my final answer of negative root 3. So what you guys should be doing after this, you should do your bookwork 7.5 like usual. Then we are going to do the classwork tomorrow, Wednesday for our Zoom check-in, and Thursday for your mini test on this. Please ask me if you have any questions. Check your notes. This builds so much from the previous weeks. So if you've kind of skipped a week or missed a week, please go back and watch those videos. There's a lot of information in each of them. Remember, we're just doing one topic a week, so please really try to devote your time to really focusing on them and getting them done as they get posted, so that way it doesn't all build up. Anyway, hope you guys are having a good week.